Welcome to a video on solving quadratic equations. In this video, we're going to learn how to solve quadratic equations using the quadratic formula. Let's get started. The quadratic formula that can be used to solve any quadratic equation written in standard form, which is ax squared plus bx plus c equals 0, is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. This is where a, b, and c are the coefficients of x squared x and the constant term, relatively speaking, from the standard form of the quadratic equation. Before we look at a few examples, let's look at the types of solutions to a quadratic equation. There are three possible cases for the number of solutions to a quadratic equation in standard form. It's important to remember that a solution to the quadratic equation in standard form is also known as the horizontal intercept of the parabola. On the far left of the screen, you can see an example of a quadratic equation that has exactly one real solution. This is where the graph of the parabola touches the x-axis at exactly one spot. In this case, there is one real solution, which would be the x-coordinate of the vertex. In the center of the screen, you see what is usually the most common case, where a quadratic equation has two real solutions. Visually, this is where the parabola crosses the x-axis in two different places. There are two real solutions. The third and final case is when the parabola does not cross the x-axis. In that case, we say that there is no real solution. However, if you are asked to use the imaginary number I, this type of quadratic equation would have two complex solutions, so depending on which types of solutions you're looking for, the third parabola would either have no real solution or two complex solutions. Here are the directions on how to solve a quadratic equation using the quadratic formula. The first thing we need to do is to rewrite the equation in standard form, which is ax squared plus bx plus c equals 0. Then we'll identify the coefficients a, b, and c. Then we'll substitute a, b, and c into the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. And then we'll simplify completely. Before we look at examples, let's talk about how we'll write our final answer. Occasionally, you'll be asked to write your answer in exact form, and other times you'll be asked to write your answer in approximate form. When you're asked to write your answer in exact form, you will leave the square root in its most simplified form. When you're asked to write your answer in approximate form, you'll use your calculator to round the square root to a specified value. For example, in exact form, we would leave the square root of 3 as square root of 3. This is completely simplified as square root. In approximate form, I would use my calculator to approximate the square root of 3 as 1.732. Let's look at a few examples. First, we'll start by solving the equation x squared minus 3 equals 3x by using the quadratic formula. The first thing we need to do is we need to rewrite this equation in standard form, which means that we need to set it equal to 0. To do this, we need to subtract 3x to both sides of the equation. This will give us x squared minus 3x minus 3 equals 0. Now this equation is in standard form. Now let's identify a, b, and c. A, which is the coefficient of x squared, will be equal to 1. B, which is the coefficient of x, will be equal to negative 3. And c, which is the constant term, will also be equal to negative 3. Now let's use these values of a, b, and c to plug them into our quadratic formula. So we'll have x is equal to negative 3 plus or minus the square root of negative 3 squared minus 4 times 1 times negative 3 all over 2 times 1. So everywhere I'm seeing a, b, or c, I just replace those letters with the values from this equation. Now let's go ahead and simplify this. So we'll have x is equal to A negative times a negative gives us a positive, so this will be positive 3 plus or minus the square root. Negative 3 squared is 9. Negative 4 times 1 is negative 4. Times negative 3 will give us positive 12. All over 2 times 1, which is just equal to 2. So this will give us 3 plus or minus the square root. 9 plus 12 is 21 over 2. Since the square root of 21 cannot be simplified as a square root, we can write our answers in exact form by writing 3 plus the square root of 21 over 2 and 3 minus the square root of 21 over 2. You can use the free online calculator Desmos by going to desmos.com. From the Math Tools menu, select Scientific Calculator, or you could also use the graphing calculator. I'm going to use a scientific calculator here. So if I want to type in my first solution, which is 3 plus square root of 21 over 2, I'm first going to use the fraction key, or you can use the division sign on your keyboard. In the numerator, I'm going to type 3 plus the square root of 21. In the denominator, I'll type 2 and then hit enter. So my first answer in approximate form would be 3.791, rounding to 3 decimal places. Now, if I want to find the second approximate value, I can actually just use the commands to copy, either Control or Command C, and paste, either Control or Command V. Edit the sign from 3 plus the square root of 21. Let's make that 3 minus the square root of 21 and press enter. My second answer in approximate form, rounding to 3 decimal places, would be negative 0.791. So depending on how you're asked to write your answer, you could either write your answer in approximate form or exact form. Now let's take a look at our second example. Let's solve the equation negative x squared plus 3x plus 10 equal to 0 using the quadratic formula. This quadratic formula is already in standard form. We can tell that by seeing that the equation is set equal to 0. So we can go ahead and identify a, b, and c. A is the coefficient in front of x squared, so a will be equal to negative 1. B is the coefficient of the x term, so b will be equal to 3. And c is the constant term, so c will be equal to 10. So let's go ahead and plug the values of a, b, and c into our quadratic formula. So x will be equal to negative 3 plus or minus the square root of b squared, so that will be 3 squared, minus 4 times a, which is negative 1, times c, which is 10, all over 2a. So this will be 2 times negative 1 in the denominator. So x would equal negative 3 plus or minus the square root. 3 squared is 9. Negative 4 times negative 1 would equal positive 4 times 10 would give us positive 40, divided by 2 times negative 1, which would be negative 2 in the denominator. So x will equal negative 3 plus or minus the square root of 49 all over negative 2. Since the square root of 49 is equal to 7, we can keep simplifying these solutions. So x equals negative 3 plus or minus 7 over negative 2. Now let's find the two exact values. So this will be negative 3 plus 7 over negative 2 and negative 3 minus 7 over negative 2. Once again, since we can keep simplifying, we should keep simplifying. You want to keep going until you can't simplify anymore. So negative 3 plus 7 will be 4 over negative 2. 4 divided by negative 2 will just be negative 2. And negative 3 minus 7 would be negative 10 divided by negative 2. And negative 10 divided by negative 2 is positive 5. So we have two solutions to this equation, -2 and -5. This is one example where the exact values and the approximate values are exactly the same. And that was because the square root was a perfect square. We could simplify those to integer or whole number values. Now let's take a look at our third and final example. We need to solve the equation 2x squared minus 4x equals 3 using the quadratic formula. This equation is not in standard form because it's not equal to 0. So let's start by rewriting this equation in standard form. To do that, we need to subtract 3 to both sides. That will give us 2x squared minus 4x minus 3 equals 0. Now that we're in standard form, we can identify the coefficients a, b, and c. A is the coefficient of x squared, so a will be equal to 2. B is the coefficient of x, so b will be equal to -4. And c is the constant term, so c will equal -3. Now let's go ahead and plug these values of a, b, and c into our quadratic formula. So x would equal -b, which means we need to do negative minus 4 plus or minus the square root b squared, which would be -4 squared minus 4 times a, which is 2, times c, which is -3, all over 2a, so this would be 2 times 2 in the denominator. Now let's go ahead and clean this up. So we would get x equals times -4 would give us +4 plus or minus the square root. -4 squared would be 16. And then -4 times 2 would give us -8. Times -3 would give us +24. All over 4 in the denominator. So in this case, we have x is equal to 4 plus or minus the square root of 40 all over 4. Now the square root of 40 is not a perfect square, but it can be simplified. The square root of 40 would be the same as the square root of 4 times the square root of 10. And the square root of 4, that is a perfect square, so this would be 2 times the square root of 10. So let's replace square root of 40 with 2 times the square root of 10. So this would give me x is equal to 4 plus or minus 2 times the square root of 10 over 4. Now we need to simplify this in exact terms. Now a common mistake that is made is people often want to cancel these 4's out. But you cannot cancel like this. This is a mistake. Because 4 in the numerator is being added and subtracted to 2 over the square root of 10, you cannot cancel those 4's. Instead, we need to be able to factor the numerator. So let's erase that. What we do know is in the numerator there are 2 terms, and 2 goes into both 4 and 2. So we could factor a common 2 out front, and this would be 2 plus or minus the square root of 10 all over 4. Now we can cancel 2 goes into 2 once and 2 goes into 4 2 times. So our solutions would be x equals 2 plus or minus the square root of 10 all over 2. That means that our exact answers would be 2 plus the square root of 10 over 2 and 2 minus the square root of 10 over 2. Let's use the Desmos scientific calculator to convert these values to approximate values. Once again, I'll use the fraction key, and then I'll enter 2 plus the square root of 10 into the numerator, divided by 2, and then press enter. So our first solution in an approximate form would be 2.581 rounded to 3 decimal places. Now let's copy and paste that, change the addition sign to subtraction, and then press enter again. And the second value will be -0.581. Rounding to 1 decimal place, my approximate answers would be 2.6 and negative 0.6. That's it for this video. Thanks for watching.